Hey, Geography 231 students, welcome to your week 2 tutorial. Um, Make sure that you've already gone through the lecture notes and listened to the lecture slides for this week and before you do this. And also, as a heads up, I will only be walking you through exercise 3A. And so the assumption here is that you've already done exercise 2, 2A, 2B, 2C on your own. Okay, so I'm not going to walk you through exercise 2 because really it's just a data collection exercise. You go through the table, looking at the spatial data that you're going to need, attribute data, the various data sets, preparation steps, all of that. So you do that on your own. Pause this video if you have to. Go ahead and take care of exercise 2, and then we'll pick up on exercise 3 together. Okay, so that's what we're going to be doing now. Okay, so the table that you see here in front of you on screen is what you should have completed as of finishing exercise 2. And then exercise 3A picks up on this concept of project preparation. Okay, so the first thing we're going to do now in 3A is figure out which parcels we're going to be using to essentially figure out what portion of the city of Los Angeles covers the river area. Okay, so in row 1 of the table, in the dataset column, enter parcels. So dataset, land parcels, we're going to enter parcels. In row 2 under dataset, we're going to enter vacant parcels. So how do we determine the land parcels and the vacant parcels? We just use these two feature classes that we've already got in the dataset. Okay. Next up, we're going to look at row 2 in the preparation column. There's a step that needs to be done. We are going to be joining a table to parcels. Join table to parcels. And what this is all about essentially is that we need to find out which parcels are vacant, but we only have a single parcel layer. The data that corresponds to what is vacant is in a standalone table, a database file, a DBase or a CSV file, I think it might be. Something you would open up in Excel, not something you would view through ArcMap. So in order to figure out which parcels are vacant, you have to do a join, an attribute join, which you should all be fairly familiar with at this point. Okay, so preparation means we need to join the table to this parcels layer. And that will give us the portion of the parcels that are vacant. Okay. All right, next we're going to need to calculate the parcel percentage, or excuse me, parcel acreage to satisfy the third requirement, which is the size, essentially this quarter acre or more. Okay, quarter acre or more for the park. So in row 3 under dataset, we're going to enter parcels because this is specifically coming from the parcel layer again. All right. This should be capitalized there as well, since it's referring to a feature class. Then under preparation, enter calculate area. Okay, and when you're through with these steps with the data requirements table, make sure you save it because you're gonna build on it. Okay. All right, so that's enough for the data requirements table for now. Go ahead and minimize that, and we will likely come back to that at another time. Okay, so go ahead and open up ArcGIS Pro, your LA River Parksite project, and then in the catalog pane, which you should still have open from last time. If not, just go ahead and click on View, Catalog pane to bring it up. We are going to create a new map called Lesson 3A. Now, I've already created the 3A as I walked through this before, so instead, I'm going to create one called Lesson 3A version 2. Hopefully that doesn't confuse you too much here. Okay, so yours should just be called Lesson 3A. All right, so we've inserted our map, we have renamed it. Next, the requirement in row 4 is that the new park be within the city limits, right? So any new park that's built along the LA River has to be within the city of Los Angeles as per the requirements of the project. So in the catalog pane, we're going to expand the folders. I have mine already expanded, so consider them not. So expand folders, expand the park site folder, expand source data, expand the city of LA, and then add the vacant parcels DBF. Parcels DBF. So a DBF file is a database file. That's something that is tabular data that can be viewed through Microsoft Excel, but it doesn't actually have any spatiality built into it. All it is, if you right-click and open the table, is it looks like an attribute table. It looks just like any feature class attribute table, but there's no actual feature ID. So if you notice this first column says OID, that stands for object identification. And so these are objects, these are records. There are 29,461 records from the DBF file, but they are not features. So if you notice in a feature class, you'll have the first column be FID, feature identification, because those represent actual vector features. Objects versus features sound fairly similar, but if you see a table with only an OID field, that tells you that it's not a feature class. Okay. So we've opened the table. In the city code field, you should see the first field or first cell says Los Angeles. Well, we want to find out if any of these vacant parcels are outside the city of LA. So the quickest way to do that is just to sort the city code field. So you can either double click it, and that will make it sort ascending, or you can right click and do sort descending. So do ascending, do descending, and notice that no matter which way you do, both of them, the top cell is always Los Angeles. That tells you that every single feature, every single record here is a vacant parcel in LA. Okay, so that's good. So that means that we don't have any vacant data outside of the city of LA. So that's one less thing we have to worry about, right? So now that we know that, we can go ahead and close that table. And then let's bring back up our data requirements table here. And in row 4 under under data set, row 4 under data set, we are going to enter vacant parcels. And that is because it is the DBF file that will help us determine whether the area that contains the potential park area is within the city. We know that anywhere, any parcel that joins with vacant parcels is within the city of Los Angeles. All right. Next up, let's in the also in row 4 under spatial data. I think I might have missed a step here, but you should have had cities in row 4. Oh no, sorry, I'm just looking at the wrong cell. My mistake. So under spatial data, this is something we've done in exercise 2. You did this on your own. You should have had cities in this spatial data column for within city limits. We're actually just going to go ahead and delete that now. And then let's see, enter, let's see here, enter cities. Then under attribute data, we will put in city name, because the city name field, every single record or object in that case was LA, the city of Los Angeles. Okay, next up we're going to add and symbolize the river data. Okay, we did that last time, obviously, but we actually have 2 different river feature classes. You may have not noticed that, but in the City of LA folder, there is a shapefile called LA River, and in the Esri geodatabase, there's also, in the hydro feature dataset, there is a river feature class. All right, so we've got LA River shapefile and river feature class. They both are representations of the Los Angeles River, but there are differences, and we're going to explore the slight differences. Well, one major component and one minor component between the 2 feature classes. Okay, all right. So let's first add in the. We're going to change the base map. So change the base map from streets to imagery, and that's so we can actually look at the LA River. Next up, under the Esri geodatabase, go ahead and open up the hydro feature dataset and drag in the river. Okay, so this, once again, if you remember from last week, this is every single river in Los Angeles County, even dry creek beds, rivers that have sporadic activity depending on precipitation. And the good news there is also by dragging in that feature class, it zoomed us into LA County, so you didn't have to manually zoom in. But we only want to be able to see the LA River. So last time we ran a definition query, this time, and which is I will say this is not in the book, but running a definition query is really what you should do in any situation where you just need to pare down a larger data set to a smaller data set. So you want to do that. But in this case, the book is going to have us only symbolize the Los Angeles River. So we're technically not doing a definition query. The other rivers are still there. You can still view them in the attribute table, but we are only going to symbolize the LA River. The other rivers don't get a symbol, therefore they don't show up on the map. So how do we do that? Make sure that the river feature class is selected. It's hard to see the color in my contents pane because it's this kind of beige color, but don't worry about that for now. So go ahead and make sure it's selected, click on Appearance, then click Symbology. And then by default, the single symbol option is chosen. So every single river looks the same. It uses the same symbol for every river. We're going to change that to unique values. Okay. And now here, the book is slightly different from the software, and that's just because the software has been updated a little bit. So the button is still the same, but the way that it's listed is slightly different. So it says click the Add Values button in the book, but actually the button is now called Add Unlisted Values. So it's not a major difference, but just be aware of that. Make sure the name field is the field in field 1. Go ahead and click on that Add Unlisted Values button. And then it's going to ask you, it says more than 100 unique values were found. Do you want to generate the full list? We're going to say yes. And if we're talking like every river on Earth, you probably would want to take that into consideration because that would take a long time. But for LA County, it's not that many. So we want to find Los Angeles River. So you can just do a quick scroll down. There's Los Angeles River. Okay. So we're going to select it and hit OK. So now we have just symbolized the single Los Angeles River. All other values are just given this default gray color. We're going to take care of that by doing something also as indicated in the book. So right here it says show all other values. If you click the more button, show all other values, we're going to uncheck that. So that gets rid of all values that are not the Los Angeles River. Okay. The next thing we're going to do is change the symbol color for the LA River. So just go ahead and click on the format symbol. You click on the little default color of the river icon there. It's called format symbol. And then make sure that the properties tab is selected. It might have gone to gallery by default, so make sure that properties tab is selected. And then for the color, we're going to go ahead and make it, I don't know if it's apatite or appetite blue. I feel like it's apatite, but I don't know. So anyway, it is this blue right here, apatite. Go ahead and choose that. Apatite just seems like an odd name for blue, but there are a lot of different colors that we don't typically think of in the color tray. So we're then going to change the thickness to 2 and go ahead and hit apply. All right, so now we can actually see our river in LA County. And then the next thing we're going to do is symbolize the other river. So we just brought in the river feature class from the Esri geodatabase, but now we're going to bring in the LA River shapefile. And before we do, just zoom in a little bit here, right? Clicking the right click and drag down, and it just gives you a slightly better view of the LA River. Let's just kind of quickly take note of the kind of geographic extent of the river. It starts up here in the San Fernando Valley, the far western valley over here, runs across the valley, the southern end, makes a dogleg to the south there by Dodger Stadium and the zoo, heads south, through South LA, down through Long Beach, and then out into the San Pedro Bay. Okay, so that's the route of the LA River. So let's go ahead and make sure that you have the catalog pane open. It's under Park Site, Source Data, City of LA, and the LA River shapefile. Go ahead and grab that, drag and drop onto the map. And if your color happened to be similar to mine, it's fairly hard to tell the difference between the two, partly because it's a thinner width. It's a width of 1, and also in my case it's gray. So unless yours was like a bright red or something, it might have been hard to tell the difference between the two. So let's go ahead and symbolize it so that it actually stands out. So go ahead and click on the color patch here to bring up the Symbology pane. We're going to change the color to Cretan blue, which is a very bold blue. Size 2 point font, or thickness, excuse me. And go ahead and hit apply. Now, if you can see that, you should be able to tell from the resolution of the video, this section of the LA River cuts off right here. But why does it do that? Well, we'll find out in just a bit. Okay, but for now, just suffice to say, we have two different river feature classes. One connects all the way through the entire length of the actual LA River. The other one ends right about here. Okay. Okay. So let's find out why. So what we're going to do is last lab, you created a Los Angeles layer file. We had taken all the cities in the United States. We had done a definition query to just Los Angeles, and we made it that hollow with a yellow outline, no fill. And then we created a layer file from that. So you should still have that. Okay, you should still have that in your Maps and More folder. So go ahead and in the catalog pane, open up Maps and More, and there should be la.lyrx. Go ahead and drag and drop that onto the map. And if all goes well, you should see it there. Now, if for whatever reason, now you drag and drop it onto the map and you get like a connection error with a little exclamation mark saying that the data source can't be found, you can just add in the original cities layer, which is under boundary, city.ply, drag and drop that onto the map, run a definition query so that name equals Los Angeles, and then make it hollow fill with a light yellow outline, and that will bring you up to speed. So you can pause the video and go ahead and take care of that now if you need to. But moving on, let's first answer the question, why do these two rivers have different lengths? Well, now we can see that it's not an arbitrary location where the river, the LA River shapefile cuts off. It cuts off in the city of Los Angeles. Here's the city boundary right here, and sure enough, here is the end of that LA River section. Okay, so that shapefile has been clipped to the city boundary. Okay, so that answers that. All right, so let's see here. Hopefully you've already zoomed to the layer. If not, let's go ahead and right click on the Los Angeles layer and zoom to layer just so we can kind of get our bearings again. Go ahead and open the layer properties for the Los Angeles River, excuse me, for the Los Angeles layer, not the LA River, the actual city of Los Angeles. Go ahead and go to the properties for Los Angeles and then click on definition query. Okay, so in my case, I still have my definition query turned on, name equals Los Angeles. You should too, okay, you should as well. But if for whatever reason, as I said before, if you added in the data and like all the cities were showing, or you got the little error exclamation mark, you can recreate that definition query there, okay? Now while you're here, go ahead and click on the source tab and just notice the location. So the location is in the Esri Geo database. So even though we're seeing only one city, it's still the original data, the entire data set of every city in the country. It's still there, but it's been queried down to just Los Angeles, okay? Okay, you can go ahead and close the properties for now. And then let's zoom in on the source of the LA River. So I know we use the term source in GIS speak, but we're talking about the source of the river, the headwaters of the LA River. I use that term loosely because there's not much of a headwaters. But if you look here in the far northwest end of the river, you can zoom in. You can use shift and drag if you'd like, or you can do right click and drag. But we want to get down here to where the LA River starts, and then the book asks you to set your scale to about 24,000. So that's 1 to 24,000. You can just do 24000. You don't have to do 1:24000. And so now that gives us a kind of a closer look at where the LA River starts. And it's actually, you can see two different flood channels actually meet right here. And this is the official start of the LA River. I don't know what these two little channels are. They probably have got some local name. But what we're going to do is we're going to pan along the LA River, and we're going to go all the way down to where the LA River stops in the southeast. So the easiest way to do that is to hold the Q key and then just move your mouse. You don't have to click at all. So we're just going to kind of follow it down here. I'm going to auto hide that so you can see better. So I'm holding Q, and I'm just moving past a nice little golf course there. I don't know if any of you are from Los Angeles. You might know some of this geography better than me. I go to LA for Dodger games and occasionally a concert or something, but I don't spend a lot of time in LA. It's a good, there's Dodger Stadium. It's a great world-class city, but I don't like traffic. If I could get to LA without sitting in traffic, I'd go more often, but not a fan. Okay, so sure enough, here is the end of the LA River shapefile, right there, just beyond the boundaries of the city of Los Angeles from this shapefile. But remember, there are multiple versions of data. Somebody could have used a different older version of the LA boundary. Maybe it cuts off at this bridge versus the more accurate boundary that follows these various parcels. Okay, so that's the end of the LA River shapefile. And notice there are a few differences aside from the Esri geodatabase feature class going south of the city boundary. You also can see that there are different kind of segments that veer out, like in this case here. The Esri feature class kind of takes a little dogleg there. It's just a bit more segmented and a little less spatially accurate, whereas the Los Angeles LA River shapefile is very smooth and really does follow the actual meander and shape of the LA River without taking too many inaccurate kind of cuts. Okay. All right. So now that we've compared the two LA River feature classes, we can bring up our requirements sheet once again. And then in row 5 for LA River, under dataset, we're going to put in LA River. And that tells us that we're going to choose the LA River shapefile versus the Los Angeles River feature class from the Esri Geo database. Okay, so when we previewed this data set in lesson 2, we saw that the river was comprised of 265 features. You can combine them into a single feature class using a geoprocessing tool called Dissolve. And so we're not going to do that now. And it's actually in lesson 6, which I actually don't have plans for us to go that far into this particular book. But know that if you've got 265 segments of a river and you just want one single segment, you would use the Dissolve tool. And essentially that just dissolves them all together, as the name implies. So in row 5 under preparation for near LA River, we're going to do Dissolve. When that tells us later on that the geoprocess we need is the Dissolve tool. Okay. All right, so you can go ahead and save your project at this point. Save your table. Now let's see here. Yeah, I think I'm actually going to end the tutorial at this point because the remainder of the tutorial is the same thing I've just been doing with you. Sorry, the remainder of this particular exercise. You're just going to go through and you're going to compare the LA Parks layer. So you've got two different versions of parks, and they have varying differences in their extents. And you're going to do something very similar to what we just did with the two river versions. And you will also be updating your data requirements table along the way. So once all is said and done, once you've gotten through all of the steps up through 3B, you are then going to, for the actual assignment or the deliverable, what I'm looking for is your uploaded final version of your data requirements table. And it should look like this. Let me pull it up real fast. Like this one, but here we go, completed. So you're going to want to obviously don't just copy mine. I want you to actually do it on your own, but make sure that you've got it all filled out. Upload a copy of that to Canvas, and then also I want you to tell me the length, the distance between the headwaters and the mouth of the end of the LA River within the city of Los Angeles limits using linear feet, and you will be able to derive that distance once you finish exercise 3B. You're going to have to set the map projection to NAT 83 state plane zone 5. Okay, so you'll see how to do that. Basically, I just want you to literally draw, using the measure tool, draw a measurement from the northwest corner to the southeast corner and do a straight line measurement from one side to the next. So it's obviously not going to be indicative of the actual length of the river. It's going to tell you more or less what the hypotenuse is, since it sort of makes a triangle in that case. But that's what I want to know. And I need to know the length in feet to the nearest 1,000. Okay, and there you can just type that into the Canvas text box. So those are the two deliverables I'm looking for this week's lab. It's nothing too outrageously difficult. Again, these first 2 weeks are just to help you familiarize yourself with ArcGIS Pro. Next week, we're going to get into building geodatabases. We are going to do exercise 4 from the textbook, and that will actually be the last the last chapter that we do in this textbook for now. I may circle back around to it later on in the semester, but we're going to just get through exercise 4 next week. Then I've got a couple of handouts based on census data. This is a big year for the census because obviously there is one, the Census 2020. So I'm going to talk a little bit about how to work with census data, how to do some spatial analysis on census data, and then we're going to move into our Making Spatial Decisions textbook after week 6, I'm going to say. All right, so that sums up the tutorial. And until next time, have a good one. Bye-bye.